In this video, we are going to be talking about the root mean square velocity. Root mean square velocity means the speed at which the average, mean is average, the average molecule moves. So let's say we're finding the root mean square velocity of carbon dioxide molecules at room temperature. So carbon dioxide molecules are moving around in the air at room temperature, and they have a certain average speed. If we heat carbon dioxide molecules up, they will move faster. If we cool them down, they will move more quickly. But every single carbon dioxide molecule is not moving at the exact same rate. It's impossible to calculate what the speed at which every single molecule is actually moving at, but scientists know the average velocity that a specific molecular atom is moving at, and that average velocity is based off of the temperature and the molar mass. So hotter things move more quickly and lighter things move more quickly. So we're going to be looking at two equations. The first one is this one right here. Kinetic energy is equal to 1/2 mass times velocity squared. This is a basic kinetic physics equation that will tell us the kinetic energy of anything. So if you throw a ball, you can take the mass of the ball, the speed of the ball, and it will tell you the energy of that moving ball. But in this scenario, we are talking about molecules and atoms. So the kinetic energy equals 1/2 the mass, and we can't really get the mass of a single atom. What we use is we actually use the molar mass times velocity squared. And what we call this velocity, we change it to U in chemistry. And we will be solving for the root mean square velocity, that's that URMS, and that's equal to the square root of this. That's our root mean square velocity. That line on top means that we are taking an average. So again, it's not the speed of a single molecule, it's the average speed of all molecules, all carbon dioxide molecules, or all oxygen molecules at that specific temperature. So that's the first equation. And the second equation is another kinetic energy equation, and this is for particles. And kinetic energy is equal to 3/2 RT. So again, it's dependent on T, and R is a constant. So we have these two kinetic energy equations, and we want to solve for our root mean square velocity. So we want to solve for this guy. So we're going to set our equations equal to each other, and we are going to solve for our root mean square velocity, which, so we need to get U squared alone. So first we multiply by 2 to get rid of our 1/2, then we divide by m to get rid of our mass. What we do to one side, we have to do to the other side. So we end up with 3RT over m equals U squared. And again, that m is our molar mass. We want to get the square root of this, the root mean square. So we take the square root of both sides. So that would be the square root of 3RT divided by molar mass equals U squared. And the square root of U squared would just be URMS, or U. So the square root of 3RT divided by molar mass equals URMS. And this is the equation that we will be using. So, one last note is this R. We are using a different R, and it has different units. So, R now equals 8.314510 joules per Kelvin times mole. And I know I said we're using a different R. This is exactly the same R, but with different units. So since we've changed the units, the number also changes. This unit J, joules, actually means kilogram times meter squared divided by second squared. And a velocity, the units for our velocity are meters per second. How far does it move in a given time? That would be our speed. So meters per second. So if we have this equation, we're going to have our URMS equals the square root of 3 times 8.315, and I'm just going to write it out, kilograms times meters squared divided by Kelvin times mole times second squared, times our temperature, which is 28 degrees Celsius, so that's 298 Kelvin, divided by our molar mass of helium gas, so that is 4.0 grams per mole. So look at what units cancel out. We have Kelvin cancels out, mole cancels out, and we want meters per second, and notice since we have a square root, meters squared divided by second squared is going to give us our units meters per second. So we're left with this kilogram and gram. So since our R constant is in kilograms, we're going to have to change our molar mass into kilograms as well. So again, to go from 4 grams into kilograms, it would be 1,000 grams for every 1 kilogram. So we would have 4.0 times 10 to the negative 3 kilograms. So you can go ahead and replace this number here. So you're going to do the square root of 8.315 times 298 divided by 4 times 10 to the negative 3rd kilograms. Go ahead and plug that in your calculator. And hopefully you got that our root mean square equals, we're going to use, in our problem we were given 3 sig figs because we added. So we're going to say 1,360 meters per second. So this is the speed of helium atoms in a room at 25 degrees Celsius.